have come here to talk about big data analytics. So when we take big data analytics, the topic is very huge. So the time that is provided, we cannot go into what nuts and bolts in each of these concepts. So what we thought is to somehow cover what is big data and what is the useful of big data analytics and what we are going to gain from big data analytics. So before moving further to the next slide, I would like to ask one particular question. If we take in Sri Lanka, what is the mobile device that is mostly used by the people? Whether it is Samsung, Nokia or Apple. Anyone? Samsung. So most of the people have told Samsung. The reason is information. They have seen around them people using Samsung devices a lot. So they have used their brain and thought about this and they are predicting. That is what we are going to do in here. When we have lots of data, we won't be able to do a predictive analysis using our brain. We use computer to do with our programming skill and using some scientific skill, we merge them together and we come up with some analytical models to predict. So to confirm the answer, I have shown here a graph from the search term with all these keywords with the time passed. So you can see with the time now currently we have Samsung in the high rate. So that is correct. The same thing applies to the mobile device connections also. So there are Etisalat, dial-up and so many connections. But in this graph, we can think a lot of things. You can see in 2009, there is a peak level for Airtel. The reason here is because Airtel introduced their brand or the mobile connection to Sri Lanka on 2009. So there was a trend, I still remember my friends were telling, Shah Rukh Khan is there, A.R. Rahman is there, now they are going to beat the dial-up because they have lots of marketing strategies, but it didn't work. So what I am trying to say here is, we can look at the data and from the graphs that we provide, we can come to different conclusions. So more data means it's not the same thing. It's something new, something different. So from this difference, we are going to solve lots of problems. It can be a personal problem, or it can be a organizational problem, or internal, or even the world problem also we can solve. So here I have pointed out some day-to-day life problems here. If we take IoT, I think in this meetups, lots of talks have been gone about IoT. Using IoT platform, we will be able to get lots of data when combining with the real world. But what is the useful of having a data without having the big data analytics part? So combining these IoT devices and also big data analytics, we can solve lots of problems. So if you take a simple problem, most of the people has sleep disorder, right? So those kind of things are like personal problems. Right? So we need to have a conscious about our health. So using the IoT platform, we can implement all the devices around our bed and track our sleeping cycle so that we can provide a visualized about our sleeping cycle and what's happening while we are sleeping. So this will allow us to consult a doctor and show at the end he will provide insight about and provide a good advice what needs to overcome these problems. And also there is another interesting problem. Usually when I go to supermarket, my mom will give me a list of items. So after I reached home, again my mom will tell, Ane Pota, I have forgot to add one list, basically a sugar, right? So this is another frustrating problem. I need to go back again to the supermarket and buy the item, right? So using IoT platform, we can identify within our fridge what item has reduced or what item I need to buy. Using these real-time data analytics, it will provide a notification or SMS to my mobile device so I can buy whatever I want. The same thing, it applies to the home security also. So what I want to emphasize here is the data is available in everywhere. It's all about the big data analytical part. If that is not there, it's not worth of having lots of data.
Okay, so when we talk about big data, the analytics is always there. I mean, we will have the data, then we have to run the analytics. But why do we need to run analytics? This comes with the problem of the business use cases, right? So someone will have a lot of money, then they want to earn more, then they need some business model to improve their business system. So these are the three things that we have to think when we are thinking about applying big data. The first thing is data. Then the second one is technology and also the business expectations. So when we think about data, yes, there are a lot of data, but the most important thing is whether the data is available. If it is available, we can move forward. What is the next thing? So it is technology. So inside technology, the first thing we have to think is, can we consume all this data and make it understandable to the computer? So that again depends on the data, but then we have to improve our technology to match our data. Then we have to also think about the platform cost. Like, is this feasible? I mean, we will have a cool technology and then we will have a cool set of data, but whether we will get the return of investment. And we have to also think about agility of our system because the world is changing. So can our system survive in next few years? And also, all these things are to give some business expectations, right? So if the business doesn't have an expectation, there's no point of going through data and going through improving technology. So that's why we need business expectation. So normally in any business there are two things. One is the digital experience. So those are targeting the end users. Maybe those are recommendation systems, maybe some semantic analysis to identify who are the customers we want to market on. Then also there are strategic initiations where we will give proper information that will help the management to take proper strategical decisions. So that is the new business model.
So whatever we say, the data is also important, right? So I would say data is basically a worth of a diamond because everyone want to protect their data, but due to the technology eras and all, the data is available everywhere. So I have provided here some certain areas. One is the legacy data that you can get from internal data. It can be a legacy data or digitalized data even. And also with external data like Facebook, Twitter and Instagram, there are so many data that can be extracted from external data side. But IoT is something different. It's basically opening up a different paradigm where you can convert the analog data to a digitalized data. So you have more data. Even though if it is unstructured, the beauty here is we can use our big data analytics platform to do all the analytical model. Even though it is unstructured data, we can convert them to a structured way and try to identify patterns in our predictive analytics.
But to do this, first we need to process this data somehow, right? Which means we need to collect this data. When we talk about IoT, most of these things will be streaming data. So in IoT, I believe you have talked about things like Kafka, how you can use subscribe and publish and subscribe services, and also we can use things like MQTT, and we will use normal socket connections to stream if we are using our own methods. Then somehow all this data should be ingested into our data sources, right? So to do this, so first of all, we will have set of ELT processors that will grab this data, and one option is it will save it for the batch processing, and it will also forward the same data set for the real-time analytics. So in here we will have the real-time streams, and also we will have the normal file dumps that we used to call big data. Normally those are like DB dumps and log files of the system, so those are also injected into the system. So once it is been injected, then comes the next layer, which is the actual processing layer. So in here we will have two things. We will have the real-time analytics side. So like we talked in the previous speech, we will use things like Apache Streams, Apache Storm to process these things real time. But to do that, we need the built models. I mean, otherwise we will have only a rule-based created by someone else. To create those patterns, we will use the batch processing. So every day or every month, we will run our batch processors. We will update our models. Then we will run methods on this model on real-time analysis, and it will either trigger a separate application, or we can use a dashboard application to see our analysis real-time. So that is the real-time analysis part. And from the batch analysis, now what we want to keep is, we want to keep these source files without changing, right? Because we don't know, maybe in 10 years time somebody will come again with a cool idea that can utilize the same data set and come up with something else. So if we change the original data, and if we saved a modified version, what will be happen is some data will be lost, right? So today we will think that it is not important, but previous times someone will figure out an algorithm that can utilize those data. So in the batch processing, what we normally do is we will stage them into multiple stages. So we will have the raw data, then we will have the set of filtered data, then probably categorized data. So ultimately this will end up in probably separate text files, and we will use some indexing servers, key value stores, databases to keep this metadata where we can easily access it. So from there onwards, we can get reports and charts and all those intelligence from other applications using this metadata.
So far we have talked about what is big data and what is big data analytics, and what sort of a technologies we are using. That will be covered in our next slides, and mainly the pipeline. But all these things we are doing for what reason? That is the main question, right? So like I mentioned in our previous slide, it can help to solve a lot of personal problems like our health issues and all. But also when we think in a industry side, it can solve a much more better problems. Like there are people in industry who go through all the data, analyze those data. I mean, with legacy data, they normally go and check on all the Excel sheets and try to figure out what is their KPIs. So KPIs means it's the key perform indicator that will allow us to keep our standards in the industry. So basically using all this data, using the big data analytics, it will allow us to come up with different models. From that we can come up with different graphs, statistical models or probability model or combination of all these models. Then it allows us to think in future also, where we can solve lot of customer satisfactions, right? If we are unable to satisfy the customers, we can come up with, we can say a person is, we are introducing a logo, right? And they feel they are losing their customer. So using our analytical tools and all, we can show them because of this logo we are losing the customer. So they can take some strategic initiatives to overcome their problem. And also at the end, what they think is to increase their sale. They need to have their revenue high. And also they can create their own business models through analytical. There are business BA people, they can think in different angle using this graph and come up with different business strategy, and they can incorporate in their marketing plan. And also there are so many competitors, right? So the KPIs includes all the competitors' data also. So combining not only the industrial data but also the competitors' data, a combination, we can provide lots of information in a visual way.
So these are few technologies that we are currently using. So the first one is Hadoop. So Hadoop is the famous big data implementation. So it is sort of the platform that actually implements all of the other technologies that we are talking about in here. And the next one of most important thing is Solar. So Solar is based on Apache Lucene, but Lucene being, it's sort of low level to us. But if you want a standalone service where we can easily index few documents, maybe change a configuration or two, and get our search done, maybe integrate NLP, maybe have business logics inside it. So Solar is a good option. Solar is also supports clustering, and you can also deploy it in Hadoop server itself. So which means it can expand to your data, as well as it can have the enough flexibility to support your data changes. And also the next one is the MLlib. So that is something comes with the Apache. So it's a machine learning library. It is really important because currently most of the people are using things like Apache Mahout, and also from Mahout they are moving most of these things to MLlib as well. The reason is, like, with the new technology there comes the speed, which means we need fewer resources. So that is one of the main reasons that we are moving into MLlib. So that is for the machine learning. So you can use all your models, and you can do real predictions. And also Apache Kafka. It is the one that I talked before, which is the publish subscribe services that we can use. Now it is really important in terms of IoT, because most of our devices will basically create events, and we need to push it to some service, right? But we don't know who will consume the actual messages. So it's a good solution where we can use maybe labels, and we can publish it. So anyone who has access to it can utilize the channels and consume it. And also, if you are really new to machine learning, it's a good place to start, which is scikit-learn, which is based on Python. Underneath it uses some Fortran libraries as well. So it is fast enough for a real-time application, but it has a really good documentation, and it's really easy to learn. So that's a good start point for someone who's maybe more into devices and less into big data analysis, or maybe machine learning and those stuff, but it's really easy to learn. And also the most important one is Spark, which is now the mostly it's not really mostly used, but it's like it's the new technology that's coming into the wheel. So Hortonworks, which is a very famous distributor of Hadoop, actually pushing Spark really well with their Hadoop platform, which is Spark streaming, because it's lightning fast compared to the normal MapReduce jobs, because it's based on Lightbend's Akka platform. And also we have the Apache HBase, which is a column family based databases. So whenever you want to put one of your files details into a more accessible location, that is the choice. And also Elasticsearch, although it is not belong to the same family, it is also a good indexing service. And also something which is really important here is Apache Storm as well. That is for complex like event stream processing. So those are the technologies that we are currently using to process IoT related data.
So we have been talking about all these technologies and the problems and how to solve, but how this is being derived, right? That is the main important thing, because now the trending word is basically the data science. and the data science where it falls will be dumped inside the big data platform. And using big data platform, we can do the processing and the data analysis part. So that will drive using the research component. So this is where in the data scientists will play around. Then from that, basically we are trying to get some information, so that metadata information that we provide, that we got from the big data analytics, it will be stored inside the big data platform, like my colleague mentioned, HBase, as a storage device. From that, we are going to provide a different digital experience. That is the new application that here I have mentioned. From that, the users will use, so you will get more money from that, more investment. From more investment, you can invest that money to the research. So this is how it is being driven. So until you have lots of money, you can put lot of those money to the research part, where people can do innovative things by looking at the data. It's beauty, right? So now we have been talking about a lot of theories and lot of information and all. So now we have created a small demo, right? But we won't be able to do the analytical part in real time, but I will show you a scenario, right? So what we did is, we dumped a Facebook data, right, a dummy data, right? And there was a question always when I talk to my friends, if a male and a female uploads an image, they normally say female gets lots of likes than male. So it is an hypothesis, right? So just assume the H note is an hypothesis, that is, girls get more likes for their profile P. So here we are going to identify using big data analytics and whether the girls get more likes or boys are getting more likes. So the data that we got is basically in an unstructured way. So you can see there are lots of information. So the data science, normally what they do is they will go through the data set and identify some patterns. They run some models and see what basically we can retrieve. So from this, what we have done is we have created a structured format. So what we have done is, from the unstructured data, we have created a structured data and dumped inside our Hive table. So it can be like, there are so many components, so it will take time to describe all these things. So just keep that word, like Hive is another language, so there is a Hive table. So we have added those Excel files and dumped inside the Hive table. Now the easiest way is, there are so many languages to do analytics. So for example, Pig, Hive, R, and so many things. So the Hive is the most easiest one because it's a SQL language. So I wrote a small query here, I will show you, to identify who gets the most like. So these are the queries that I use to identify, right? So from here, these are the Hive queries that we are executing. So I found there is a like received attribute from the data set, and from that I am trying to identify who gets the highest like. So the result will be, after executing this, so you can see there are 2 females and 1 male, but we are now talking about hypothesis, right? That male can be here. Any guesses? He can be an artist, right? So if a male wants to get more like, he should be a celebrity. So the answer is female gets more likes. So hypothesis 0 is true. Then another thing I always come across in different discussion is, who initiates the first friend request, whether girls or boys? So the answer is, most of the people, from the information that they have got surrounding them, they say it's male. So again, it is hypothesis. So let's confirm that using big data analytics. So I have created two analytical job here, a SQL language that is Hive, and I found that girls count is very less, that is 685, but boys count is 1525. So boys always initiates the friend request. Now we have created so many examples, but with the time constraint we won't be able to show all these things, but at latter part of this session we will be able to show. So we have some R language, quick scripts and Spark jobs that we created from unstructured data to make it a structured one. But we have another interesting demo using Spark Stream. I hope we will be able to show it. Yeah. So we were discussing about Spark Stream where you can analyze data in real time. So this is a very small demo that we created where you have to input some data and output it will do something, like say it will print something. So you can't do like very analysis in a one machine, you should have a cluster for that. So for the demo perspective we have created that one.
Okay. So something about Spark first. So normally what we are trying to use is Spark streaming. So something that you need to learn about Spark streaming first is that yes, we call it streaming, but they are also processing the same, they are exposing the same things that we would use to process a file. So basically what they are doing is they are chunking the stream into separate sections and process them as separate files. So we call them D streams. So in here, what we have done is we have a very small Scala application that has a small data set which is profiles, and profiles mentions whether it is male or female and the age. And also we have some store to keep our data, and we have a pattern to process our unstructured data. Then we have our Spark streaming related configuration. So it is really simple. You just need the configuration, then you need the streaming context. Then you can open a shortcut that actually listens to the localhost 9999 port with the storage level of memory and disk. So instead of this shortcut connection, you can also choose if you want to consume a Kafka, you can specify it here. If you want to consume MQTT, you can specify here. So it's really simple to consume a streaming data source and create a variable like this. Also it is called variable, it's a value. Then we are mapping the likes variable, and we are applying that pattern to identify whether we are getting the same unstructured data. Then we apply to the profiles. Then we use a sort of MapReduce jobs based on the files that we have, and a sequence of files. Then finally, once we have it processed, we are also sending the output to another stream, to another shortcut. So this could be a third-party application that can be triggered real time. So shall we run this? Okay. Then to create the two network interfaces, I'm using Netcat. So this is our input source, which will be a sort of device, maybe an IoT device. In here, what we will have is our end application that will get the process data. So I'm going to like someone's profile picture now. So where did I start? This is the same pattern that we have. Yes, right? Username likes someone's something. Cool. Do we have some here? Cool. Okay. Oh, okay, I don't have the network one.
So it's always challenging when we try to do a real-time demo, right? So sorry for about the technical issues. So later on we can
Yes, we'll proceed.
proceed with the next one. So hope you enjoyed our demos. So if you have any clarification, you can ask end of the meetup session. So at the end, I want to just highlight one point, right? So all these things that we tell is basically we are like a magician at the end, because using the skills that we have, using the science, combining this some mathematical side background, some programming skill, we can basically using the legacy data, we can try to understand what is already been happened, and also we have the capability to explain what is basically happening, and we can also explain what will happen in future. Thank you. Yeah, and we've been asked to ask 2 questions. So some first question.
So we talked about 3 things that are needed to create a new business model, right? So can anyone explain what are those 3 things?
Data, technology, and business.
Correct.
And we have been talking about so many technology, but one specific technology my colleague explained that will help us to basically to do a search engine. So can anyone specify that particular technology? Using that technology itself, we can provide a full-fledged search engine. Anyone? Hussein? Yeah, that is the underneath part, but there is.
Solar.
Yeah, correct. Thank you very much, everyone.